Okay, these are the 11.1 notes, page 5. One more example with expected value, and then we will go ahead and hop back into standard deviation. So, example 5, this is basically how it works. We got a term life insurance policy that pays the beneficiary a certain sum of money upon the death of the policyholder. So, we have premiums that must be paid annually. Suppose an 18-year-old male buys a $250,000 one-year term life insurance policy for $350. The probability that the male will survive the year is 0.998937. We want to compute the expected value of the policy to the insurance company. So we've got two things that can happen, and I'm going to make my table a little bit differently. I'm going to go horizontal here. So we have an X and a P of X. The insurance company pays out 0 if the 18-year-old doesn't pass away, morbid as that is. And the probability of that is 0.998937. The insurance company pays out that $250,000 if our 18-year-old passes away, and the probability of that, which is the 1 minus 0.998937, is 0.001063. So our expected value is 0 times 0.998937 plus 250,000 times 0.001063, which gives a cost for the insurance company of $265.75 per policy. Notice up here that it says they charge $350 for that policy. So the insurance company, in the long run, is making money. So 6, we're going to go back to our basketball example. We have a 0.38. This is a smaller example, so I do want to find our mean and standard deviation by hand. Hopefully that way it makes a little more sense when you go into Excel to do it. So we have this probability of 0.38 on 2 points. That's from page 2. The expected value of the distribution, let's see if I can squeeze that in here. That 0 happens, 0.01 has a probability of 0.01. That 1 has a probability of 0.10. Our 2 has a probability of 0.38, and our 3 has a probability of 0.51. When we multiply and add those, we get 2.39 as our average. So our basketball player scores, on average, 2.39 points per visit to the free throw line. Can they score 2.39 points in one visit? No, they cannot. But if they were to go to the free throw line 100 times, we would expect roughly 239 points out of those 100 visits. Okay. So let's talk about standard deviation here. We are going to go ahead and compute this one by hand, at least I am. You are welcome to hit pause here, plug this into Excel, Make sure you are getting the correct values. And then come back and compare. That is a 2 there. I'm not sure what's going on with my Apple Pencil. And then here we get 0.61. We are going to square those values. And again, sometimes it just helps to see everything. Negative 1.39 squared, and we get 1.9321. We got a negative 0.39 squared, and that is a 0.1521. And then a 0.61 squared, which gives us a 0.3721. And now I'm going to take these values and multiply by the probabilities. So again, 7121, times 0.01. I know a lot of times when we do this in Excel, it's hard to make sense of where everything's coming from. Uh, 0.38. And 0.3721 times our 0.51 gives us a 0.189771. When I add all those together, which is our variance, to find our standard deviation, then we take the square root of that. And we get 0.8785. So the average distance from our mean, that 2.39, is 0.8785. Okay.